This is a video to demonstrate how control flow works with iPd. So if we want to send PD messages from the iPhone application, essentially we just need to create a patch with a number of inlet objects, and optionally some outlet objects if we want to receive any feedback. So first, I have a simple test patch here, and it has two inlets and one outlet. We'll talk about the outlets later. When iPd first starts up and your patch is loaded into PD, the number of inlets and outlets in your root canvas will be stored in these two arrays right here. And this is very convenient because as soon as we have the list of inlets and outlets, we can essentially control our PD patch as if it were an abstraction or subpatch from our iPhone application. And the way we do this is using a number of these methods in our iPd adapter class. So if I was wanting to touch the screen to send a bang to the first inlet, then I would have to use this method down here to send it to our first inlet, and then that would start our metronome, and then we would get bangs coming out of our outlet. For output, it's a little bit different because right now there's an object here on the patch called the iPd outlet, and this essentially is kind of like a proxy object. Eventually I want it to be able to attach to all the default PD outlets. So for instance, if I were to replace this iPd outlet with this outlet, the same thing would happen, except that iPd outlet that I just deleted will automatically attach to whatever outlet objects we have in this patch. What that means is, whenever there's a message coming into this outlet here, that message will be passed on to a hidden object that I coded specifically for this project called the iPd outlet. I'll just open up that right there. And so the iPd outlet is essentially just a hacked version of a PD outlet. It should emulate everything that an outlet does, but the difference is that it will forward messages to the iPhone application process. Right now, the iPd outlet only accepts bangs as the output, so every time we get a bang, this method will be called. So here's what it's going to look like on the device. I just have a demo app running right now, and as you can see, there's a counter. It says bang count equals 0, and as soon as I tap the screen, it's going to send a bang to my first inlet of that patch I showed you, and then it's going to start playing the random sounds because the metro object will have been activated. So here we go. So every 500 milliseconds, the color changes and a sound plays. So in a nutshell, what I just showed you is that every time a bang comes into this outlet, it's going to forward that message via the bang out selector in our iPd outlet, and that will notify the iPd adapter that that message has arrived. And from there, you can essentially do whatever you want. If you were programming a game and you wanted the screen to flash every time there was a laser firing or something, you could patch that in so that every bang coming out of that outlet would cause an OpenGL class to cause the screen to flash, for example. And obviously in this example, whenever we send a bang, we're calling a method that just changes the screen color and plays a random noise. So the possibilities should really open up as more of this control flow is implemented in iPd. So I'll be keeping you updated on that in the weeks to come, and that's all for now. Thanks for watching.